Hello, and wherever you are in the world, welcome to this webinar. We're pleased that you're joining us for today's session, and before we hand over to our panelists, we'll run through a few housekeeping details. Firstly, there's a member of IOSH team operating behind the scenes to ensure the smooth running of this webinar. They are available to help you should you need it, and you can message them using the chat function, which is at the bottom of your screen. You will also see a Q&A option. If you have any questions relating to the content, please post these here. A Q&A will be carried out towards the end of the session, and we'll get through as many questions as we can. At the end of the presentation, a feedback poll will appear on your screen. Please take a moment to complete this, as we value your feedback, and this helps us to improve our service to you and shape future guidance. Any value you gain from this session can be used as part of your CPD portfolio. We do not issue formal certificates of attendance for our webinars, but you will receive an email confirming your attendance, details of which can be used to record your CPD. Information on CPD can be found on our website. Where we have been given a speaker's consent, these webinars are recorded and will be made available on our website. You'll also be able to find a list of all our other recordings, as well as details of any upcoming webinars. Finally, details of all of this information will also be posted in the chat box shortly. We would now like to hand over to our panelists and hope that you, as listeners, enjoy the session. Thank you.
Good morning, everyone. My name's David Evans. I chair the IOSH Hazardous Industries Group, and on behalf of the committee, I'd really like to welcome everyone here today. We're expecting some really high numbers. We had nearly 1,000 people register interest, so we may well get in the 400 to 500 people attending. I'd like to remind you that a copy of the session will be streamed onto YouTube and be available after, if any of your colleagues would like to watch it, or indeed if you'd like to see it for a second time. Today we're welcoming Ian Travers. He's talked with us before. Many of you will remember him, some excellent talks on process safety. Dimple, can we have the next slide, please? Just a couple of words before I hand over to him on the Hazardous Industries Group. We're really starting to grow quite a community on LinkedIn. Perhaps less so on Twitter, but LinkedIn is our main feed to keep in touch with members and interested parties, stakeholders. And we welcome lots of input, comments, posts, send us material. You'll see on the right the latest of our newsletters, which will be up on the IOSH site soon, if it isn't at the moment. And we welcome stories, and guidance, notes, direct us to anything you find that's interesting, and we'll include information on it. And finally, this is the first of our webinars this year. We hope you find it interesting. We've got another one booked at the moment for the 21st of April, when the European Process Safety Centre is going to give us a talk on how to learn from incidents and to share a lot of the work that they do on incident analysis and preconditioning of problems around major hazards. So please do join us for that. There should be a link up on the IOSH site in the next few days to book from that. But let's have a look at Ian before I hand over to him. Dimple, can we have the next? There we go. Ian, who I say is a member of the committee and has talked to us on a number of occasions before, brings with him an extensive experience in the investigation of major incidents, root causes, and experience working with individual companies and sectors. And he's had input into many of the, what I would call European and global standards, reviews and documents. Recently retired from the HSE as a deputy director. So I really ought to say hello, Ian. Chemical regulations, 25 years experience, and he holds the Institute of Chemical Engineers Franklin Medal and they don't give those away to people who are not very, very knowledgeable and very committed to the standards. So for today, I think it's enough from me. Just a couple of reminders on the housekeeping. Please do post questions through the Q&A. With 400 to 500 people, we aren't possibly going to be able to get around everybody, but we'll try and take a selection at the end. And certainly Ian, I know, will review the questions. We do keep copies of them, and we'll try and get back to as many of you as we possibly can. So that's enough from me. I'll join you at the end for the Q&A, and it's over to Ian. Good morning, sir.
Hello, David. Hello, everyone. Thank you very much, David and IOSH, for inviting me back. It's always a pleasure to come and speak to IOSH and IOSH members on topics that of interest, and particularly for the delegates joining on this webinar. I'd like to thank you for your attendance. I hope you get out of it what I put into it. So I'm going to speak for about 40 minutes, go through some presentations, and then leave plenty of time at the end for questions. So let me share my presentation. Please, someone shout if you can't see that. I'll take it as a yes if everyone's quiet. So this session about risk assessment, this is an itch I've been longing to scratch for a long time. And you're my friends who have agreed to listen to me work through some issues in my own head. And hopefully, while I'm doing this, I'd stimulate some discussion and an interest on your behalf. So maybe you pick these things up. I've been at these issues, risk assessment, for a long time. I was trying to work out how long I've been in occupational health and safety, and then I frightened myself when I was doing the calculation, because it's 47, 48 years I've been doing this. So that's quite scary, really, isn't it? I've lived this process virtually the whole of my working life. However, let's get into this, and let's talk about, I always think in outcomes. That's my first thing. Whatever I'm talking about, I always want to know, what does it do? Not how does it do it, what does it do? What is the kind of purpose? What is the outcome of risk assessment? I do a lot of training and guidance with organizations in major hazards and understanding process safety. And risk assessment is really about determining the degree and extent of a harm or adverse outcome that come from an incident, thinking about what could cause it, the initiating event, and then trying to work out whether we've got enough safety control and mitigation measures to reduce the risk of such an event to an acceptable level. That's a bit of a mouthful, really, and so I kind of wanted to say, well, what is my problem? What are my itches? What's bugging me about risk assessment that I kind of want to get to grips with? This was my starter for 10, if you like, these short bullet points. First thing is, and I've seen this so often, particularly after events and things have gone catastrophically wrong, people take the results of risk assessments as an absolute, almost guarantee of the absence of risk or harm, a guarantee of safety. You've assessed the risk, it's safe. I mean, I've done a lot of work recently in the last year on COVID and workplace safety under COVID, and people are saying, is it safe? And the answer is no, of course, it can't be safe. Because there's no such thing as absolute safety. The safest thing to do would be stay at home and not leave the house and not meet another human person. And then you're probably safe from COVID. But anything else, you're taking a risk. So the fact that things are taken, almost as an absolute guarantee, particularly those who've not been involved in the risk assessment. So that's a challenge I'm throwing out to people who undertake risk assessments. How do you kind of convey that this isn't a guarantee, it's a kind of assessment? Okay. And considerations and the uncertainties that you took into account, or people take into account in reaching the outcome or the conclusion, are always forgotten. So I've looked at HAZOP studies and retrospectively and found, well, look, it recommended exactly what has gone wrong in your HAZOP study. Why didn't you kind of spot it? And they said, well, we only took the actions. We didn't look at the things the HAZOP committee decided not to do. And yet that's, I think, often just as valid. The decision making of a set of persons' discussions and considerations when doing a HAZOP are just as valid as the answers they come out with. Okay, my pet hate are risk matrices. Okay, and I'll explain that as we get towards the end of the program. No, I don't hate them, but I think they are the most problematic part of this. The fact that we safety specialists turn risk assessment into some kind of ultra precision tool, and we talk about risk being tolerable if as low as reasonably practical, which if you went down to the local bar or cafe and kind of said, I'm gonna get in my car and drive home provided that it's tiff or lob, people would look at you like you had two heads. And yet we're quite happy to use that terminology to try and have discussions within our workplaces and our work activities. And then we do go even further and say, do you know what? The risk of you dying driving home in your car can be, or maybe 1 in 10 to the -6 per year. Okay, and that's an enormously complicated thing to get your head around. I still can't do that, to be honest. And that's never going to be understood by non-specialists. And it's the non-specialists who are exposed to the risk, not us risk assessors, if you like. And what the ultimate risk value is dependent on is forgotten. So if you've got a whole lot of control systems in place, if you're thinking of things like bow ties or layers of protection analysis that got you to the conclusion that the functioning of every part of those components has to be spot on to give you the risk value of 1 × 10 to the -6 risk of a fatality a year, that just gets forgotten. And therefore the value and the security that risk assessment gives is a very wobbly set of foundations, really. And finally, most organizations who have use risk assessments either because they're legally required or because they want to do it obviously to reduce the risk, design new plants and understand their hazards, they cannot hire in people like me to do it for them, and therefore they don't own the outcome, because what they're focused on is the solution. Let's get in, Ian, do the risk assessment, tell us what it is, Ian, so we can just kind of act on what you say. So not necessarily part of the process, don't own the outcome, don't understand how you got from A to Z in that process. And I've looked with a couple of companies I've worked with on risk assessments done by other people, and they can't articulate how did they get to that outcome. So I want to tell you a couple of things first, and that is, I don't know whether it's a blessing or a curse, but we're risk takers. As a species, we take risk. We thrive on risk. Okay, and we've developed as as a species because we're prepared to take risks. And I often used to think, well, people take risks for because they derive a benefit. Otherwise, why would you put yourself, in the front seat of a car driving at 110 kilometers down an auto route, 2 meters from the car in front? Why would you do that if it wasn't kind of some benefit? Why would you kind of get in an airplane if there's no benefit? But we've even got members of our species who take risk for no apparent benefit. If you kind of do the thought experiments and say, well, if you could chat to your cat, let's say, you can have a conversation with your cat and you say, I'm going to go to the moon. And your cat might say, why? And you say, because it's there. And the cat might say, well, is it warm? Is it cozy? Is there good food there? Is there something, there are lots of other handsome cats or whatever. Oh, no, none of that. There's nothing there. There's no air to breathe. And it's really dangerous and hard to get there. So your cat would go, so what are you doing it for? And we can't explain. So we're risk takers. as a species, and we just have to kind of get on with it. The second thing is we do risk assessment almost constantly, all the time, every day, in everyday activities without thinking about it. So we do subconscious risk assessment because we're good at it, and if we can put that in our subconscious part of our brains, there's no energy really expended on it, and therefore we can kind of do these risk calculations in our head. Okay, so I want you to look at these two situations here. I want you to spend a minute or so, you probably had a good look at them anyway while I've been chatting, and I want you to answer the question for each one, is it safe? Okay. So how did you get on with that? I'll come back to it in a minute, but let's go through the process, the thought process that we use. And this was a set of questions I drew up for the UK Health and Safety Executive post Bunsfield. There were 3 questions, but there's 5 really. How could it go wrong? So I'm going to get in my car. How could it go wrong? Where and when would it most likely to go wrong? I might think when I get on the auto route and when I'm driving fast, that's where, or when, if there's a lot of traffic, and what do I have in place to prevent, keep me safe? So I've got a car that's mechanically sound, etc., etc. I've got brakes. I've been, I can stop the car, all of that. So which of all of these are the most important? So, and you can even resolve that saying, well, it's the distance I keep with other vehicles and the speed I drive according to the road conditions. And then we can say, well, which of them are the most vulnerable? Well, actually, it's me. It's my decision time, my ability to stay awake and alert to spot things developing in front of me is the most vulnerable part of this control system. And have I got sufficient controls in place, and how do I know they're any good? So we kind of do this instantly, and so when we go back to this photograph, what did you think? What did you think of the construction site in terms of is it safe, and what did you think of the process facility there? So sorry, I'm jumping about. So I hope you were able to answer the is it safe on the right hand side? No. And what did you do? You went through a process that said, well, those guys working on the top of that construction site could fall down. And if they fell down, they could be seriously injured, probably be killed. And is there a way to reduce the risk and make it safer? Yes, put up scaffold, wear harnesses, etc., etc. But did you think about the hazard? Okay, we talk about hazard identification, risk assessment. So kind of what's the hazard there? Okay, and the hazard isn't a consequence, it's a fundamental feature of the work activity that can give rise to harm. So if you think about it, the hazard is gravity. So the thing that could cause those guys to fall is only gravity. And gravity can't be turned off. It's an innate part of being on a planet of a certain mass. So whenever you're working at height or whether you're at height, gravity is the hazard. Plain and simple. The consequences are multifold. Those guys could fall off, things could fall off the building site, etc., etc. So let's look at the refinery. What's the hazard or hazards, and is it safe? And now you can't answer that question, can you? Okay, you can't look at that photograph and say yes or no. So you can't do your instantaneous risk assessment as you can on the right. So for high hazard industries, we need to kind of unpack the process and start going through this. What could go wrong? How could it go wrong? What are the hazards, etc., etc.? What are the sorts of threats that give rise to a loss of control? What preventative measures do we have in place? What's the likelihood of them working? What mitigation measures? What's the likelihood of those working? And at the end, what would be the worst kind of outcome? Now, the thing about hazard identification and risk assessment, and this is a subtle point, well, not really, hazards are generic, okay? Gravity is gravity everywhere. Okay, it changes slightly with altitude, but at the heights we normally work, it's more or less the same. Gasoline is always flammable. Chlorine gas is always toxic. High tension electricity is always, will find a route to earth or ground as quickly as it can. And risks are always context based. So this process that we call risk assessment sits between a set of generic hazards, and they might be, all sorts of hazards that could be in that refinery or that process plant. But the conditions in that plant and the circumstances and the context are going to be different everywhere. So one of the things we have to make sure risk assessment does is it gets us through this risk profile to develop exactly the right control measures. Okay, miss any out, you're taking too much of a risk. Put in too many, you're wasting your money. So there's no one size fits all outcome, unfortunately, against even what looks like a straightforward or process plant. So please remember that hazards are generic, risks are context based, and risk assessment is taking the hazards in the context in which they exist and making decisions about control measures. So, and we've got multiple hazards and many ways that can lead to harm. Hence, if you're not familiar, the bow tie concept that, there's many things that can give rise to a loss of control. And if you lose control, it can go in many directions. So it might kill and injure people. It might cause damage to the environment. It might cause a lot of press and adverse media, a business reputation loss. You might even end up in court or being fined and all of that. So that kind of bow tie model is a great way to think about hazard and risk. And then we're putting in enough barriers between us and the harm to prevent us losing control, and then putting in some mitigation barriers afterwards that might rescue us if we do lose control. So we go through this step-by-step assessment of risk to answer the question in process industries that we answer almost instantaneously in other circumstances we encounter in our lives. And the other problem we have as risk assessors in the general terms is that our decisions in our day-to-day lives about risk, our instantaneous decisions, are based on experience usually, or learned experience. So we've seen car crashes even if we've never had one. We've witnessed people falling, or we've even fallen over and fallen down things ourselves. So we've got kind of some personal exposure to the hazard and the harm that we can play on to make a decision whether it's safe or not. Hopefully, we've no personal experience of ever been involved in a large-scale fire or a toxic gas release or something, a large explosion. So we've not only can we not determine just by looking, is it safe enough, we've no frame of reference to make these decisions. And that's a problem. And we often overlook that issue in risk assessment. It's definitely, I think we do. So we've got to kind of go through this step-by-step process for high hazard industries. What can go wrong? All of the threats, all of the ways it can go wrong: corrosion, overpressure, over temperature, over speed, etc., lead us to a loss of control of the hazard, and it could lead us to a whole range of adverse outcomes. So we've got to kind of do this, identify the cause, the threat, identify what loss of control looks like, identify the consequences, and decide how big those consequences were, and finally decide, is that safe enough for us? Okay, that's the whole point. Is it safe? Is it safe enough? That's what we're doing risk assessment for. And how do we make it safe? So the how and where things go wrong, I always use this simple example of ship offloading gasoline into a big tank and then distributing the gasoline by road to customers. There's a number of scenarios in here about where things can go wrong. And I always start my thinking in risk assessment by answering that first question. So it could go wrong at the ship to shore connection. It could go wrong in the storage tank. It could go wrong in filling the road tanker. And of course, once the road tanker leaves, the road tanker can go wrong on the road. So we've kind of got these scenarios, and we've got these causes developing as initiating events. And we go into that a bit deeper through things like fault trees. So how could we lose containment during ship offloading? The ship to shore connection could fail. Well, how could that fail? The hose could fail, or the coupling could fail. How does a hose fail? So the reason we do this structured analysis in risk assessment is that we can't miss any of these. So the hazards, gasoline in this case, doesn't care about us. Okay, every day of every week of every year, gasoline is flammable, and if there's a failure mode by which we can lose containment, it can be due to any of these. The gasoline doesn't care; it will just cause a flammable vapor cloud. So unless we identify all of this in a rigorous way, we can't put in. We can't cover these with control measures, because every one of these failure modes is a realistic failure mode, and therefore we kind of need control measures suitable and sufficient for each of these threats. So we've got to go through this kind of analysis. And then we've got other techniques like HAZOP, where we don't just look at the failure modes, we look at the process conditions. So we apply questions like more of, less of, none of, different type of, etc., in a structured way, stage by stage through that set of plant and equipment, from the ship to the pipeline to the tank to the filling lines, the gantry and the tanker. So including HAZOPs. And we're doing that to answer the question, is it safe? What do I need in place to make it safe? Have I got enough? So we're kind of building up these layers of protection, these barriers. There's a prevention in depth against the form of harm leading to a loss of control. And then if the loss of control occurs, reducing the consequences by shutting down, safety systems operating, emergency arrangements, and etc. So we're building this picture in our minds as risk assessments, saying, well, this is necessary. We need one of these. We need one of those. We need one of those. And the kind of mix of barriers or control measures. This is now the latest thinking from the UK Energy Institute and the US Center for Chemical Process Safety, 5 types of barrier, things that do the function, which is detect a condition, decide if it's okay, act if it's not, by various ways. So passive hardware, if you're driving your car along the auto route, there should be central reservation with a barrier, physical barrier in the way to stop you drifting off into the other lanes or the oncoming traffic. It works just because it's there. Okay, and it's a physical presence. Active hardware, that's all the technology, safety systems that don't need a human involved. Once it's designed and installed, it detects you've overfilled the tank, it decides you've gone beyond a safe level, and it shuts off the incoming line. And then a combination of active hardware and humans. So the technology makes the detection, because we don't fill gasoline tanks with somebody leaning into the manhole cover anymore. There's a sensor by, a level sensor. It detects the level. It rings a bell when it gets to a certain point, and the person decides, it's getting too full, turn it off. And then totally active human, where there's no technology involved. That might be things like site surveys, walking down a pipeline, checking for rust and corrosion and impact damage and things like that. And then things like continuous barriers. So I always use the example, things like, earthing protection. So if you get static buildup, it will automatically dispense it. So how often do things go wrong? How bad could it be is the next bit that we have to work on in risk assessment. So really frequent threats and really serious outcomes are, to get more attention than low-level threats. And then how often, this is where we start to get on dodgy ground, if you like, thin ice, because who knows how often a flexible hose fails. Okay, your own personal experience is probably you've never had a flexible hose fail in the whole history of your facility. but flexible hoses do fail. So you can't use your personal experience to say, do you know what, I've had that for 30 years and it's never gone wrong, and if I buy a new one, it's going to last 30 years again. Think about televisions and your washing machine at home and all that kind of stuff. So we use some other people's personal experience, and this is from HSE, from their failure rate and event data document, which you can get online, and it tells you how often large vessels fail. Okay, but does it? What it says on average from the data that's been taken into account, it could be on 5 occasions every 10 to the minus 6 years, you get a catastrophic failure. And once in every 10 to the minus 4 years, you get a major failure. But we just take this data as real and accurate. Okay, how bad? Well, lots of us have no personal experience of events like this, thankfully. So we, again, on the personal experience side of risk assessment, there's nothing we can bring in. So we have to kind of do risk modeling, and actually the risk models on how bad now from all the various pieces of software are actually very good. So I think we're okay on working out how bad. We're just not very good on working on how often. So we've worked out how often the event could occur. How often could we get a tank failure? And that's based on a number of assumptions. So the initiating event, how many times could we perhaps overfill the tank or try to overfill the tank? And then we put all these barriers in place and sub barriers that they're depending on for their function. And but are they going to work? Okay. And this is one of the points I've made about risk assessment. We assume, because it's our way of coping with risk, they're perfect. Usually we assume because we put something in place, it's going to work, because we've no counter experience that it won't work. And we can only make those judgments by doing this thinking. And I always put failure into 2 boxes. Things that fail nicely, that's predictably according to engineering calculations. So I know this bearing is going to last 5 years and before it starts to fail, or this seal on this pump, and I can check it over time and see it's following that trend. And if I'm lucky, things will fail with some early warning. It'll start to leak, wobble, vibrate, squeak, get hot, something like that, which allow me to turn it off and replace it before we get catastrophe. So, we can do some predictive maintenance around these predictable, nice, calculated failures. And then we have a other bunch of things that fail unhealthily and erratically. So, not according to calculations, with no warning or previous malfunction, earlier than you imagine in its lifetime, and allowing for no recovery. And guess what? Those are the failure modes of people. And people do safety, and people equally undo safety. And people do every part of process safety management, including, at the moment, risk assessments still done by people. And so us people doing risk assessments have these failure modes as well as people running plants, maintaining them, etc. So when you've built your protection in depth, your layers of protection, how good are they? Okay, what's its failure mode and what's its function? And we need to think about this in risk assessment, because we come to our magic number at the end based on the fact that we think these are going to work, but unfortunately we have no personal experience often of alarms failing or sensors failing. We've probably got lots of personal experience of people making mistakes. If you're like me, you're always making mistakes constantly. So how reliable are these things? So we can build into risk assessment which are the most important barriers, the criticality, and which are the least or most reliable. And there's some guide words here about, does the barrier fail in a predictable mode? Do you get early warning if it's failure? Can you recover if it's failed before you get right through to the loss of control? Okay, there's the correct function rely wholly or partly on a person, because if it does, it's it tends to be more unreliable. And is it the last one you've got in line? So if you think of that ship offloading the gasoline into the tank, the big tank, if the flexible hose failed, the ship is pumping at such a large rate, there's no recovery. You're going to have a large release that's going to go in water and spread a long way and evaporate, cause a very large vapor cloud. So that barrier is last in line in terms of this bow tie model. Okay, and criticality is about the contribution of the barrier to preventing the top event or preventing the consequence. Okay, and whether it's vital, important, not very good. And so you kind of should shrink your bow ties down to the real important stuff. So that exercise is about looking at reliability of the things that we're depending on to keep us safe. Yeah. And now we get into the tricky area. So somebody has to decide in industrial risk and organizational risk, is it safe enough? This isn't a personal decision like you get in your car to go on holiday and decided to drive your car. This is risk taken as part of enterprise. And don't forget, people are much more tolerable of risk if it's their choice compared to risk that's imposed upon them. So being at work or undertaking an enterprise, you're imposing risk on people, whether it's your employees, contractors, you're imposing risk maybe on the environment, you're imposing risk on your neighbors. So there has to be some decisions about what's safe is safe enough. So we use this, which is the HSE tolerable of risk carrot, if you like, triangle on the left-hand side. And we kind of do that boundary or that anchoring. So what's okay? What's totally safe? Well, if the risk of somebody dying from that activity is less than 1 in 10,000, 10 to the minus 6 years, that's okay. Okay, we'll accept that. And then what's the other anchor point or boundary and the other extreme? Well, if there's a chance of somebody at work being killed once every 10 to the minus 3 or every 1,000 years, that's not acceptable. And then there's a big band in the middle called a LARP or tolerable if a LARP. And that's the bit we have to kind of maybe focus on. So then organizations want that transposed, this set of thinking. Can you distill all of this down, please, and just stick it on this risk matrix for me? And we're not bad at doing the significance bit, the consequence bit at the bottom, okay? We probably have got, you know, if you think of that building construction site I started with, there's 2-3 guys working on the top of that construction site. If there was high wind or there was some problem, you could have 2 or 3 of them fall off and they probably would be killed. So we're going to stick it in the severe box. So we're kind of pretty good at working that out, so we can use those risk models. But then we have to do the likelihood in order to land on a box in this LARP region. So what's the likelihood of this event occurring? What's the likelihood of all of those barriers kind of working together and giving you an outcome? And then we stick it in a box and that looks okay. Okay, it's not in the red and nobody expects you to be in the green, do they? So we're going to stick it in the intolerable, and that's what our risk is, and therefore that's fixed forever. Yes, in people's minds. Somebody's done the calculations, it's come out between 10 to the minus 4, 10 to the minus 5, chance of a single fatality in a year, and therefore we're going to accept that as safe or safe enough. But actually, what have we done? We've taken a whole load of uncertainty about how often things have failed. We've taken a whole further set of uncertainties about the control measures that are in place that gives us a whole set of uncertainties about how often we lose control. And then we've added in a load of uncertainty about the mitigation measures and added in the uncertainty about the worst outcome. So we've multiplied over, you know, several stages uncertainty, and yet we still are happy to stick it in a single box, and not only do that, leave it there forever as that's it, it's safe, and yet we've no knowledge of, and we forget the uncertainties that stick there. So I'm going for this. This is like quantum mechanics, okay? If you want accuracy in one, you're going to lose accuracy in the other. So it's somewhere there. But, you know, where is it today? You know, which of those control measures may not be functioning enough that actually it's moved us into the intolerable region? Yeah, or what are we doing better at that actually might reduce the risk? So I'd be much happier if we resolve risks down to this. The problem is the demands on us as risk assessors and people who are doing, risk assessment, presenting risk. You can't present that to the board and say, we might be okay. Actually, we may not be okay, but we're probably in the middle somewhere. And if you try and present this to a regulator, good luck to you. Okay. So, but that's the reality of what we've just done. And yet we believe the single tick, don't we? We believe that rather than realizing it's this. And so I think this is a big unresolved problem in risk assessment. Okay. So, and then we dress up that single tick in this box in a lot of jargon that's probably impossible for most of the people to understand and assimilate in their day-to-day lives. So I've taken up my time. I hope I made you think. I hope I've kind of answered a few questions. And my decision was, am I going to decide risk assessment is a friend or a foe? It's definitely a friend, okay? But it's a very dangerous friend. And it's dangerous because the hazards don't talk to you. They don't care. We build in all of these assumptions about why it's safe enough, and we forget all of that. And we do that because we have to get on with our lives. We have to get on with making gasoline. We have to get on with generating electricity, etc., etc. So if we were conscious of all of this stuff all of the time, it would drive us insane. But we do need to keep our eye on exactly what the outcome is based on. And I think as risk assessors, we've got to find better ways to communicate these outcomes rather than as a fixed single point that's there forever. David, thank you.
Oh, no, it's been great sitting here listening to you, Ian. Thank you for that. You've picked a topic that I know is close to the heart of many people. I've been monitoring the chat and all the comments that are going, and I'm sure every one of our nearly 500 people could come back with a direct question. I particularly liked, before I open to the questions, you started off by saying that risk is context-based, something I very, very strongly believe in. And maybe I ought to have a dig and say that regulators are very, very bad, I think, at making that story very true. In other words, when I was a young engineer, I was told very, very clearly, if you ever do calculate risk, you've got to be very, very aware of what the sensitivities are in the calculation that you're doing. And I was always taught to ask a very simple question. What is it that may change that can cause a significant change in the output of that risk?
Yeah.
In other words, what will change now or could change, and what could change in the future? And what you're getting is a series of comparative answers. And it's the comparative element of risk.
Absolutely.
Management to make decision, not the absolute. But that again is me, and it's one of my bugbears. So I'll let you think about that. You may want to make a comment on it.
No, I absolutely agree with you, David, but not many people have that kind of level of consciousness. It's a process that's got to be got through in order to meet some regulatory demand or demand on the business to build and construct and modify and whatever, or it's a demand to make a change or a demand to issue a permit to work. And you kind of forget. So they're looking to you, it's almost like you're a medic. Give us the diagnosis. You're not going to die. Okay. Well, there's a chance that you're not going to die. And we forget, all we hear is you're not going to die. And I think in risk assessment, all people hear is that final point in, on that risk matrix. That's all they want. And I think it's for us as risk assessments to keep doing what you've said and say, yes, but.
Yeah, thanks for that. Great. Right to the questions. Theophilus came in with a really early question on the hazards, saying that he's seen some organizations use physical, ergonomics, manual handling, all sorts of things as types of hazards. And he's saying, can you elaborate on this? And maybe I could add a question of, can you refer people to a sort of a good text or tome or reference on hazards and the identification of them?
No, all you need to know is in your head, guys. Okay, please, you don't need, look, hazards are intrinsic forms of harm. And if high hazard industry takes forms of hazards and makes money out of them. Okay, hazard elimination is almost impossible. I do a lot of work in the power industry. It generates high tension electricity. That's what it exists for. So hazards are not risks. Hazards are fundamental forms of harm, and there's not many of them. Gravity, momentum, okay, toxicity, flammability, radioactivity. They're all fundamental hazards that are physical or chemical properties of the things that we work with. Okay, manual handling is an activity. It's not a hazard. Okay, what is the hazard? It's lifting a force using your muscles that may not be in the right configuration for your body to withstand that force. It's physics and chemistry, guys. It's nothing else. You don't need a book.
I thought that might liven your afternoon. Another question from Stephen Hales. Are there any audit tools for high hazard installations and activities that can be used to confirm that what you have in place is still relevant and working?
Yes, there's absolutely. I have a great one, actually. So if you get in touch with me, I'll give you the reference, and it's part of the Energy Institute high-level framework. And it looks for evidence that it's an outcome-based audit. So you're looking for evidence that these systems exist and they're delivering their outcome. So if you put in touch with me, my email's at the bottom there, I will point him in the right direction.
Okay, that's great. We'll go and do that. And something I should have said right at the start, and I want to reinforce now, is that these slides are available and they will be sent to everybody who's registered for this event. But come back to that. Right, this is a nice one. Jake is asking, any tips for presenting uncertainty in risk assessments to senior managers and regulators?
Yes, talk about your own personal life and experiences, like driving a car or flying in an airplane or rock climbing, you know, because people get that. I always tell a story. Look, my granddad, he was born in, he's not with us anymore. He's born in 1886. And he fought through the First World War and part of the Second World War. And he said to me, when I was a lad, Ian, if you wanted to go anywhere, you either walked, or if you were really rich, you had a horse, and then bicycles came along, so we could cycle. And then I saw motor cars invented and trains, and then I saw, you know, spaceships invented and aeroplanes in his lifetime. And he said, and I always remember this, one of the last conversations, and he said, now I've seen somebody go to the moon. Okay, I guarantee if I'd stuck him in the front seat of my car on the motorway, he'd be petrified. Okay, because he was not be accustomed to driving at 110 kilometers an hour, 2 meters away from an enormous lorry and a car in front. So use your personal experiences to explain uncertainties. What are you relying on to keep you safe at 110 miles an hour on the motorway? What are you relying on being on an airplane to keep you safe? What are you relying on? So I always use personal, you know, things that people understand and can relate to.
Thanks, Ian. Victoria's saying most risk assessments have a disclaimer to say the document reflects the level of risk found at the time of the survey. Do you think this should be removed? And she mentions with new technology, but I'd add, should it not give an indication of how the risks varies?
I think it should be expanded.
Sorry?
I think it should be expanded, not just what you found at the time, but how wobbly the data is that you've used to make, you know, calculations about likelihood, you know?
Yes,
because,
wouldn't it be nice to see assumptions recorded alongside?
Yeah.
You know, so that people understand you were when it was actually.
I always think the conclusions of risk assessment should always be accompanied with, this is safe, provided that, and then all of those things that it's relying on listed, so that that level gauge works, you know, that people have been trained, that, you know, people are aware of the hazards and can explain them, etc., etc. And the maintenance is done on time. So the day you're overdue on a maintenance, it's no longer safe. You know?
Yes, you know where you stand. Claire is saying, and oh, sorry, it's just jumped. I was having a look at it. So Claire, I'm sorry, I haven't got your comment in front of me. But it was to do with the fact that in environmental assessments, she's looked at using normal, abnormal, and failure, if you like, as overlays on risk assessments. Have you come across that technique?
Yes, I mean, I think you always got to, it's always a dilemma. Are you going to use the worst possible event or the most credible worst event? And I think you've got to exercise judgment to say, use the worst, most credible event, don't go down to extremes. I mean, I've seen risk assessors take into account, things like aircraft falling out of the sky. Well, okay, it may happen. Or, people looking at earthquakes in the UK. Yeah, but it's only going to wobble a bit, honestly. So, but think about flooding, because that is a real possibility and it imposed risk, at coastal terminals and things like that. So you definitely, Claire, use those kind of overlays, because you've always got to be thinking of, where's this going to end up and what's in between it, getting to the most sensitive part of the environment. And it's not just with environmental risk, it's not just the immediate, it's the risk of cleanup, because you're putting people at risk who have to go and clean up chemical spills and oil spills. That has risks in itself.
No, I agree. And a simple one for you. Emmanuel is saying, should risk assessment not be seen as a dynamic document that should be under continuous review?
Yeah, except that we've got to be practical, haven't we? Okay, in our heads, on normal risk, when we're driving a car, crossing a road, riding a bicycle, sailing in a boat, we do risk assessment. It's a constant loop. Is this, am I still safe, etc., etc. We can't do that in industrial risk, so we have to do it frequently, and frequency based on our view and the view of the risk assessor in terms of the reliability assumptions put into that set of calculations, the barriers, which is the wobbliest barrier in your bow tie, and it's people.
We're back to what's changing. What's changed in my view?
Yeah, it's people. It's people that's the weakest part.
Yeah, trouble is, like process plant, I get older these days. Do you notice that?
Yeah, I've noticed I'm getting old.
There's a webinar feedback form. Please do fill it in. This is really good. And you will like this one. I know we've just got a couple of minutes left, and I promise we will keep all the questions everybody's asked and look through them and get back to individuals on some specifics. Stephen is saying, my biggest problem with risk assessing is senior managers or directors. Try to tell them what you want, trying to tell you what to quantify the risk they want.
Yeah. No,
they don't
absolutely
want to tell
agree.
them that the risk is intolerable.
Yeah, and give me a single answer, resolve risk to a single yes, no, a black and white. No, I absolutely agree. I just noticed the chat, somebody said, falling is the hazard. No, that's a consequence, my friend. Gravity is the hazard. Okay, falling is an outcome.
No, that's true. But how would you advise, Stephen? How do you get around this problem of senior individuals trying to direct you? Because they've got this mental perception. They've got maybe...
Take them out on the plant, David.
Sorry?
Take them right to that hazard. Take them on the plant and say, look at that distillation column. What do you think? Just looks like a pile of metal to me. Well, in there is very hot, hydrocarbons at 200 psi at 300 degrees centigrade. And the only thing between that and you is that bit of steel. So how are you feeling right now? Okay. And not only that, but that steel is getting thinner every day. Every day it's losing a few of its thickness, and there'll be a point where it can't any longer stand the pressure of the hydrocarbon. So how are you feeling now? So do you want me to tell you it's entirely safe, or do you want me to say it's safe enough? Take them on the plant, but stand them near the hazard. Seriously.
But it's taking, I mean, what you're saying is very true, isn't it? It's taking it away from a paper-based exercise and getting it out into the environment where work is being done and the hazards exist. Can be seen at the time at which you're doing these assessments.
Come take a walk with me is the answer.
Great, I like that one. Okay, do you have a perception about AI, artificial intelligence?
I've thought a lot about this, David, and I think there's there's definitely a function for AI to improve our data. So if more data inputs give more reliability to those figures, you know, I shared with you from AHSE, and how they, one of the bugbears I have is that we do loads of maintenance, but we get no feedback on the condition of the plant. So when you open it up, what's the functioning of the level gauge? How far off its set point was it, etc. We just throw that data away. And I think absolutely for artificial intelligence to tell us that the you know, the data we're relying on or using is more or less reliable than it, you know, in real life than it is. Absolutely, that's the first path to go down with AI. Decision making, well, you take the emotion out of decision making. Do you know what AI will do? It will reduce the number of activities we do, because the system won't take the risk. No,
okay, its perception will be different.
Well, it'll be hardwired in. It doesn't have you know, it doesn't at the moment, does it? So I think it will decide more things are unacceptable than we would decide. I think that would be the first round till it learns and whatever. And of course, AI doesn't make mistakes, and people do make mistakes. But I'd never take the person out the system, never. Okay, because we're brilliant at diagnosis. You know, what's going on, is that okay, etc., etc. We're brilliant at the flight and fight thing.
Yeah, that's true. We do overlay our own biases on that, but that's another subject, I think. Jorge is asking, should we start complementing our risk assessments with what he refers to, or she refers to, as risk range assessments? Exactly.
I think that would be a big improvement. And then you can have a discussion around that, can't you? You know, my big tick in the middle, it covered all. I mean, that was a real risk assessment I did. I promise you, that wasn't just made up. That was the range of the calculation. So, yes, exactly. Then you can have that discussion. Well, how could we make the points smaller and further down to the left-hand side?
I mean, Phil Green agrees. He loves the size of the tick. Goes on to say that the safety culture and level of maturity, etc., within a business have an impact on the size of the tick, or is that wishful thinking?
I think that comment and that thing that came out of Texas City, that always be afraid. You know, where are you going to get that sense of vulnerability without that kind of discussion and that insight? You know, the moment you think it's okay, the moment you think it's buttoned down, the moment you think that is a pinpoint risk rather than a range of risks, is the time that you need to worry that you're in difficulties. So anything that raises that sense of, you know, being afraid, not being frightened, but being afraid, this stuff doesn't care about you, and it will, you know, wipe you out in an instant. Okay. And we've seen it time and time again, you know, in Beirut recently, and those just gone, doesn't care. That's very true. Yeah, Beirut's a very good wake-up call, isn't it? Okay, and we're approaching 1 o'clock, which is the time that we've booked for this this webinar. I'd just like to thank everybody. We've had an awful lot of people listening in today. I'd like to thank them all for joining and for the high quality of the comments in the chat and the questions. Dipple, if you're listening, I know we can get the question Q&As captured for us. Be interesting to also capture the chat, because I think there's been some really interesting comments in that as we've gone through it. Ian, is there anything you'd like to finish with? My last point is, please do join us on the 21st of April as the Hazardous Industries Group runs its next webinar, and it's over to you to say goodbye. Thank you, everyone. Thank you for your brilliant comments and your feedback. I think I've achieved my aim, which is to make you think about risk assessment, but more importantly, I'd like you to kind of take this forward and deal with my itches. I mean, you know, I'm coming to the end of my career, but let's be better at communicating uncertainty. Thanks very much, Ian. You're more than welcome. It's back to you, and thank you again, everyone, for joining us. It's been a great session, Ian. Thank you again. Thank you.